So we are going to start with Sylvia. Let's give Sylvia a big hand.
Thank you so much, Pankaj. Welcome. Do we want to do the puppy? Do we want to? Okay. In honor of the wonderful women that are in the room, that we were told that we're nurturers and we're collaborators and all that, I said to Cheryl, why don't we collaborate and nurture each other? Because her little puppy didn't work this morning. So I said, you know what? I'll give you 1 or 2 minutes of my time in my keynote for her to kind of showcase her things. So come on up, Cheryl. And I'll make sure I'm 18 minutes. He's already looking at me going,
And I'll say this, I think most of you might have seen Aibo, the artificial intelligence bot, crawling around earlier. And if it weren't for Anil actually had rebooted him, and he looks like he's drunk. He still might be having some issues. But nonetheless, it is a community of support. We're showing Aibo, the artificial intelligence bot, product that I brought to market for Sony, and he is powered by a Qualcomm Snapdragon chip. And so I'm going to set him here. And he has GPS. So what he's doing is he's actually scanning the room. He's evaluating everything around him. He won't fall off the table. He's got OLED eyes. He's got a couple of cameras on his rump and his nose, a laser, did I say OLED eyes? Haptics touch on his back. And he recognizes my voice and follows me around, doesn't pee, poo, or have fleas. So, who wants one? So that is the Aibo bot. I don't want to take too much of your time, Sylvia. All right. So any questions? Price point? That's usually the first one. So it's sold in the U.S. It's a Sony. You go to Sony's website, or you can just search for Aibo. I think it's aibo.us. But he is autonomous, so it is an autonomous bot, just like an autonomous-driven car. Like I say, it's got its own cloud plan, and he is just packed with sensors that are sensing. And so in 2018, this was a big deal because folks weren't really thinking about AI in such this way. So we were fortunate to swoop up a lot of awards, but also open up some really significant questions about privacy. Do I want an animal with a bunch of cameras on its rump in my house, right? And the reality is if you're caring for someone, yes, you do. And so in Japan, the use case is this is an elder care bot. And in the US, I use it as security. So there are many use cases that you can have with this. And I think the key thing that I'll leave you with is that the promise of robotics, and by the way, October 10th, I'll be doing a tech day on robotics, is the future of embodiment. It's the thought of these generative AI models in hybrid with hardware. So if we think now, he's not running on generative AI, but can you imagine as these things start to merge and the things that can happen in such this way? But you can see he's very well designed, pretty darn cute. And then Anil has the original, right? What year? 21 years ago of the Aibo bot. So Aibo was actually named Aibo 21 years ago. Artificial intelligence bot then. So AI is not new. So, Miss Sylvia, what do we think? Yes, so it's powered by Qualcomm Snapdragon chipset. When you buy this dog, you also get to buy a cloud plan. I think it's like $19 a month, so forth. But this is actually how you're connecting with the dog. So through computer vision, he has facial recognition. So he knows my face, he knows my voice, and so you're sending data back and forth to the cloud. He is building a preference for people. So if you're mean to Aibo, if you kick Aibo, or you pet him, haptics, this is information that's being sent through the cloud back to servers in Japan, basically reinforcing that this blonde thing in front of him is actually quite nice to him. So it is truly, when I remember the first time that I saw it in Japan, it was the question from the global CEO at that point is, how would an American market receive an artificial intelligence bot like this? And when I saw it, I was absolutely enamored and delighted with it. And I think at the end of the day is if there's a utility, there's a practicality, everyone should have it. So rip out your checkbooks, $3,200 later, you're a proud owner of an AIBO bot. All right. Thank you, Ms. Sylvia. Thank you, Anil.
Wonderful. So that's a prime example of what we're going to be talking about today. It's ethical AI. So Cheryl is a technologist. Everybody in the room is a technologist. I'm more the venture capitalist that actually invests in things like that. But I'm also a really devout ethicist, I guess, ethics person. And I was asked to come and talk about the ethics of AI. This keynote is meant to just be thought-provoking. I don't have all the answers in ethics. We never have all the answers. Socrates didn't have the answers. Today, we don't have the answers. So just having to have you open your mind and think provocatively about what it means to have AI in our world and make sure that we're making the right decisions from databases to large language models to what is being outputted so that we really think about that ethics and where data comes from. So if you see this dog right now, it's like, well, that could be a dog that helps human flourishing, right? Somebody is sad or somebody's in the hospital. They could actually bring that in and be able to help that patient or that senior or that child or anything like that. So those are the kinds of things that when you're thinking something like that, that's probably why he or she, we don't know, has large eyes, because that probably is because they're like, oh, I really like those large eyes and I want to integrate and play with this dog more. So even all those things are super important. So and I'm Dr. Sylvia Ma, by the way, so I'm venture capitalist at Ad Astra Ventures. I'm Fund 1 manager for San Diego Angel Conference. I'm the chairwoman of Stella Foundation. Lots of other things, Stella Angels and all of that. I'm also a professor at Biola University where this kind of comes in. We have an AI lab at Biola University. Biola University is Bible Institute of LA. It's a seminary. So I had to go through a lot of soul searching and write out all of my faith statements. It's about 100 pages of that to become a professor and get acknowledged by the seminary first before I could even teach business. So it's kind of interesting. So that's like the way that I'm coming in. I'm director of innovation on campus as well. So looking at all of the startups from students to faculty to, not postdocs, but to alumni. Oh, thank you so much. So there's a famous video that's out there that is the AI dilemma. Hopefully you can read that. It's a little bit short. I didn't know how that was going to look up there. But thinking about the AI dilemma of looking... You rock. Thank you. Whoop, whoop. Yes. So looking at the spiritual impact and spirituality, I'm not going to say a Christian worldview because, of course, I'm coming from that, but I know everybody has their own faith. So I just want to put that out there first and foremost. But there's a spiritual impact of thinking about deepest beliefs that you have when you're developing data, when you're looking at data, and spiritual inquiries, right? There's a lot of work and research being done by really amazing people. A lot of this all of these slides in the research are from Gloo, so GLOO, that does a lot of the Christian elements of kind of AI and spirituality. The video that I'm talking about is by Tristan Harris and Aza Raskin, and they really discuss the existence of God and the existence of AI, existence of good human ethical aspects and questions that you can ask AI, and how do we build better models to be able to have those questions answered in the best way possible. Who has heard of, let's say, the teenagers? I think it was last week, a teenager that committed suicide because he's talking to somebody on AI. Yeah, right? Who else has heard that? Yes, thank you. Yeah, so those are the things that if we build the wrong AI, well, wrong is also subjective, right? So an AI that allows for somebody to go down this rabbit hole and have an answer saying the only thing you can do is take your life, that's significant. Right? And sometimes you're thinking that as a technologist, it's not going to matter. It does matter, right? Other aspects of, let's say, ethics and data in general is, I'm giving you another example, is that, however you've gone to the to any airport bathroom or any kind of bathroom, and you're going to put your hand underneath the sink and then it comes out the soap. Who's done that? Everybody? right? Okay, thank you. That was actually the algorithm behind it did not account for dark skin. So at first, when it was being put out, a lot of people who had dark skin were putting their hand at it and it didn't work, and it didn't work, and didn't work. People were like, what is going on? Why is that not working? Sure enough, the data set that built that, which seems to be very simple, was built for not dark-skinned people. Wow, amazing, right? So those are the kinds of things that data and ethical thoughts of creating something makes a difference in the world, and it makes a difference in the world in other ways. Let's see, so like big questions are pieces of this ethical piece of purpose, life, dignity at scale, at stake. So, and our responsibility is the ethical frameworks that we establish now will define AI's impact. And I know a lot of people know this, that's why it's just like thought-provoking. Everybody knows that they should do this, but just as a reminder. Let's move on. So the moment of profound choice is that we see that there's a cultural shift. You've heard that all day. You've heard all the awesome tools that we can build. So that's a cultural shift, but there's also an ethical shift, making sure that we're building things that make sense, that make ethical realities happen. There should be a clear vision that you want to create something good in the world, right? Not something that is for evil, because if the AI starts hallucinating, they're going to go into something that's even more evil and more horrible and more things that you don't even want to see. So we have the responsibility to build correctly. There's ethical frameworks also that we should be thinking about, and that will define AI's impact on society. And let's see what else. Yeah, so the two things that I wanted to bring up as a collective here, we have so many people in the room, that we also have a collective active stewardship that we should have when we're developing anything that we're developing, okay? Next up. Thank you. So again, this is a little bit of the thought-provoking and just research out there. Glue is somebody who's doing a lot of work with churches. And I just heard the chief AI officer on Thursday at our university speak. So he's working with all faith-based organizations, typically mostly churches right now, because that's where, we all know we go after the beachhead first, right? Not the whole world. So if you want to look that up, I have all of this. I'll share this, the research with you. But they have really thought about how do we have ethics and faith-based aspects being built into AI. And a lot of pastors and, let's say, faith-driven leaders don't want to rely on AI. So how do you bring that in? So they've had conversations with faith-based leaders saying, well, if you want to reach your faith-based people, how are you going to do that? They're like, well, we want to impact 50,000 people, 1 million people with our faith. Well, how can you do that? You could use AI, but there are certain things that you don't want AI to kind of touch and manipulate, because your faith is super core to who you are and to your substituents in creating more followers in the faith that you have. So that's just something that they're working on. The last one I wanted to just have you have the awareness of is they've created CALM, so KALLM. It's a large language model called the Kingdom Aligned Large Language Model. The reason why they did that was because when you ask AI, let's say, and of course they're focused on God, I understand, and there's other faiths in this room, but they ask that there's not the relevance and the aspects of the data set that is good enough so that you could have great answers to that. Let's move on. So we know that there's promise and peril. I think we've kind of talked about that. I do only have like 4 more minutes, so I'm going to go kind of a little bit faster. So we all know this. So that's something just as a shepherding and as a responsibility for ourselves to know that we have both of them. Let's go on. So can you, yes, go down? That was a different type of way. And I created this in Gamma AI because I wanted to honor that we are an AI conference, but I did do it like PowerPoint, then go up to Gamma AI, and then still trying to figure out how it works and stuff like that. So the 4 aspects of ethical AI is purpose, dignity, relationships, and well-being. It's more than a survival that we're going through all these things. It's about thriving. So technology should not be the only tool. It should serve and enhance. So we are the ones that are creating the AI. We are the creators of AI, but AI does not create what we want to build. The AI serves and enhances, and it does not define or diminish human flourishing. So that's very, very important that we know that that's how that is manipulated. So let's go through. I'll go through that later. Well, maybe I can go that. The defining of ethical AI, because that's something that is the title of the talk, is that ethical AI is the intentional design, development, and deployment of artificial intelligence systems that prioritize human dignity, respect, fairness, transparency, accountability, and social responsibility to ensure tech serves the well-being of all. So if we have that aspect, anything that we touch in AI allows that AI to be good for best intentions. And if it does then again hallucinate or do all these other things, it is managed by that data set that we created that is about accountability and transparency and making sure there's good data sets. Move on. Thank you. Okay, yeah, so this goes back to like Socrates, right? So Socrates, I pulled this quote out from Socrates, says, the unexamined life is not worth living. So there's ethical reflection that we need to have and moral inquiry that essentially builds on what we're trying to create. And if we create in that aspect, then we know that life is going to be okay and worth living. If we create that in AI, we're good. So I like this like consequentialism versus virtue. Consequentialism is a focus on outcomes. So if we're saying, look, the outcome is X, is fine, versus we saying, okay, we're gonna build from a character and intention posture as technologists. And we need to meet with people in ethics, and we need to meet with people in academia to make sure that we're doing the right thing. And we want to prioritize love, grace, and justice in those models. I have one more minute. We've collaborative responsibility, everybody's responsible, correct? Yes, okay, good, done. I did my job today, that's good. No, next up, I think I have like one more thing I wanna go through because it's more, that's fine. That's a data sets, we already talked about that. Next. This is the go down because it's the 5 C's. We've gone through this, but just so that you guys have the 5 C's of creating ethical AI is credit. It maintains proper attribution and credit for original content creators. So that's that credit piece. Consent ensures content creators provide explicit consent for their IP use. Then it's clarity, control, and compensation. So if we're kind of always thinking about those things, then the ethics part comes through. Next up, because I want to get to the data. Next. Yeah, you guys know it's misinformation that can be created by AI. Next. This one. It looks weird from where I had it before. It's okay. And I think, can you go to the next slide? Okay, so this is coming from Glue AI. They are going to publish in 2 weeks their ethical framework that they worked with Harvard, Baylor, all these other institutions. It's like also the Center for Ethics and AI with this framework. If you go online, you can find this. Can you go up the slide before? These are the things that they're kind of creating, this flourishing AI standards. Again, will be released in 2 weeks, so hopefully we can send it out to everybody who attended the conference. It's gonna be a really great study, really deep. So when you see these things, you're like, I know these things, I know. But when you really dive in and get the data that they've created, it's just amazing. So we're thinking about relationships, vocation, finances, we had the panel before in finances, wellness, contentment, character, and spirituality. So all of those things measures AI's capacity to do so much more, but we as humans need to have that aspects of ethics to be able to flourish within this AI-driven world. So, and I'm all done, so let's go through one more thing. That's done. Yes, that's done. Yeah, I was gonna give some examples, but we've already done examples. Yeah, so just make sure that we are stewards, that we're imagining in a very purposeful way. We protect, we anticipate, and mitigate potential harm. If you're creating something, what is the harm that that algorithm or anything that you're creating will have on a bigger society? And we need to cultivate the future that we want to see. I think that's my last one. Yeah, that's it. So this is how you can get in contact with me. I'm all over LinkedIn all the time, as Pankaj knows. And if you need to have any more information, this is what we're doing at Biola. We have a whole AI strategy framework, from the ethics of AI at the AI Venture Studio, the AI Lab. We have labs on campus that are doing this, and then also the applications to help companies and startups consider AI in the ethical framework. And this is all the ways that you can connect with me. There's that Glue Research. I'm also part of the SBDC. Pankaj is too. Pankaj is doing a really great series on AI, so get connected and all that. So that's it. And Biola is also having an adaptive MBA that addresses technology, AI, and ethics in an MBA framework. So that's me. Thank you for listening. Hopefully that allowed you to think clearer, deeper, and build something that we want to see in this world. So thanks so much.
We are very fortunate to have Pradeep Gupta. Pradeep Gupta is responsible Vice President of Generative AI and Accelerated Computing. He is also responsible for deploying AI solutions, generative AI solutions worldwide. He is a visionary and in the industry. And I think we had a little logistical issue. He would have been here physically, but we are just fortunate to have him on Zoom. And Pradeep, take it away.
Okay, wonderful. Thank you, everyone, and thank you for the organizing committee for inviting me and then sharing some of the insights. Unfortunately, the time didn't work out. I wanted to be, in the room with all of you, but it didn't work out. So, being on the Zoom, and I hope I should be able to do some of the insights, and later on also happy to connect with anyone, right, who has more questions around this. So, what I think NVIDIA is right now at the center of what we are calling is the evolution of the AI, which is happening around the world. And as all of you know, we are an accelerated platform computing company, right? So just to give you an insight, why this company has done what we have done in the last 30 years and how we have thought about solving some of the very unique problems in the field of AI. And that probably will give you a good insights after looking at this slide, right? So, we are an accelerated AI platform computing company. So again, think of, we are not just a computer maker. We are a we are a computing company. We are a platform computing company, right? And that's completely changed the landscape, the way you think about solving the end problems. And to give you an idea about how that platform looks like, you can think of the 3 layers, right? As you can see at a very high level, the way we think about the full stack computing problem. As the bottom, which many of the people still thinks that, hey, NVIDIA designs a lot of chips. Yes, of course, we design a lot of chips. And then we also have our ARM-based CPU, we call it Grace. And then we have something called data processing unit, right? Which also goes in the servers for offloading some of the work which you don't want to do on the CPUs. But more important on that is we have this entire platform software. Many of you are familiar with CUDA, and then a lot of CUDA-X libraries which we have built up many years. But you think of it's a lot more software which goes in everything which we working in AI. We bundle that everything together, or we put that name together, and we call that as NVIDIA AI Enterprise. Similarly, anything which we do in the simulation or the graphics, we call that everything as NVIDIA Omniverse, and high performance computing, as many of you are very well familiar with. And at the top layer, it's basically the application frameworks. The way everyone consumes the computing today, you may think of very simple way. You're consuming it with the help of, you must be running a container or you're using an API, right? And these containers or API are either solving some generic or some very domain specific problems, right? And that's what the third layer is all looks about. So if you think about Drive, which is self-driving car, autonomous driving capabilities. If you think about like Monai, which is a medical imaging, the Modulus, which is a physics informed neural networks. So you may think of like this platform is really the platform which is vertically architected. It's a modular, flexible, and you can go and solve any domain specific problem with AI and GPU computing or accelerated computing methods. Now, last 2 weeks before, I think it's 2 weeks, right? Yeah, or a week and a half. We had our biggest annual conference, the GPU Technology Conference, and I hope some of you would have attended that. And this is like a different view of that platform looks like, right? How our AI and HPC platform looks like. So as you can see, there are many chips at this bottom. But if you go up in the middle layer, the traditional way of thinking about the computing in the past, people used to think about, do you design a nice server and you connect these servers through some Ethernet, and then you are good, right? But the way AI is actually really reshaping the computing industry, it's not only just about the compute, it's a compute, storage, and networking. And the problem is really becoming at a data center scale. And the most limiting factor, which is becoming, is really your power. So you are really thinking about how your next generation data centers are becoming very, very power efficient. They are full stack, they are very dense computing, and they have the right balance, what we think about in the storage, computing, and the networking, all the three things coming together. So we designed a lot of things, right? And the recent one is what we call as a GB200. This is a Grace Blackwell system, which is having the NVLink domain. NVLink is a connection via one GPU to another GPU being connected with each other. So you can imagine there are 72 GPUs which talk to each other at the same speed, right? And which is really needed when you're thinking about solving some very complex problems like, for example, LLM training. And at the top is really a lot of software stack, right? Which you guys remember I was showing in the earlier slide is NVIDIA AI Enterprise or Omniverse or HPC or a lot of application SDKs. These are some of the examples of a CUDA-X library, but I think one of the very important points which I would like to highlight from the last 3 slides as a part of this platform, we designed this full stack computing and with a mindset that, hey, there are a lot of common problems which are applicable at many places, right? For example, you think about like holoscan. Holoscan is really about the way you do the sensor processing, right? And you can use that at many edge applications in manufacturing. You can use it in aerospace. You can use it in designing some of the like defense systems. You can use in the medical imaging, right? So there can be multiple applications of that. Similarly, we have like today, hundreds of these libraries exist. cuLitho, which is like for our lithography, right? cuDF is for the data processing. cuOpt is really how do you go and optimize the decisions, like you guys remember the traveling salesman problem. Let me shift a bit of the focus, hey, why NVIDIA is designing this full stack, why there's so much compute is coming, what's happening in the field of AI, right? Many of you very familiar with what people in industry generally, we use a term called pre-training. Pre-training means you have a lot of unstructured data, you run your LLMs and you're really training that, right? As you know, that's very compute intensive. But one of the biggest outcomes of this LLMs and generative AI, which is happening, now you're building, what you were seeing in the last 2 slides, like the data centers, or we call them as AI factories. These AI factories are producing the intelligence, right? And for your models to be more and more intelligent, you are not just enough with doing the pre-training, right? You also need to do what we call as, not we, like it means the industry generally calls that as a post-training scaling as well as a stress time scaling. So post-training, you may think of, you may want to go and adapt to some very specific problems, right? You're kind of doing the fine-tuning to your models. But when you're really running these models, and you might have heard recently the DeepSeek, right? Which is all about the reasoning model. So when you're solving one specific problem, you are thinking about how do you go and think about that problem. You think in a multi-step, you reason about it, and that's how you get the response. And with the post-training and the test time scaling, your compute requirements will go high and high, right? But on the other hand, if you can see on the y-axis, what I'm trying to show, your outputs are more intelligent, right? So think of the AI factories which we are building is really producing the intelligence, and this intelligence becoming more and more more and more like good and better as we can have like more post training and the test time scaling. So just to give you an idea about hey why I'm talking about the post training scaling looks like when we also include the era of reasoning, right? So think of, let's say you have 100 topic areas, and there might be, this is just a CEO math, 1 million questions per topic, right? You take a 1 trillion parameter training model. So think of like 100 topics with each one is having like 1 million questions per topic. Let's say you're giving 100 answers, and for each answer, roughly you need 10,000 tokens. You're talking about 100 trillion tokens, right? That is roughly 7x more than what Llama 3 was pre-trained on. So just imagine when you really scaling out these applications in production with reasoning and long thinking, right? The number of tokens which you need to produce your answer you will need more, right? Just to give a real example, what does it mean and how I'm trying to think it through. I think this is again an example, we have shown like we can have before, but if you go and ask a model, which is a pre-trained model, right? And just ask, hey, what is NVIDIA? And it will give you this response, as you can see on the left-hand side. NVIDIA is a multinational technology company, and and it gives that response. How many tokens you need? Roughly, you need 100 tokens to do that. But on the other hand, if let's say you ask the same model and to go and solve a problem, hey, where to seat my family of 8 for dinner at a round table, and my in-laws don't get along with my parents. I hope that's not very different. That's not a surprise to many of us, but jokes apart. And my sister needs to sit next to my little brother to help him eat. Now, when LLM is thinking about to really solve this problem, it has to go through a lot of tokens, a lot of permutation and combinations, thinking through how the response should look like. As you can see in the background, in a very small, this is what actually model is actually doing the long thinking, right? And now, all of a sudden, rather than 100 tokens to respond to that answer, you need to have roughly around 10,000 tokens, which is, if let's say it's a CEO math, 50 cents per token, per million token, now you have like 100x of that cost. So the knowledge and the reasoning, these are two different things, right? And most of in our real life applications, we really thinking about with the context and with the reasoning. And that's how we go and solve the problem. And that's how we expect the Gen AI moving forward will solve the problem. So, and what does it also means for the end, for our customers and for everyone, the more the tokens you can produce and the more you can monetize those tokens. It means you can increase your revenues as well as your customer experience. Because if you can give this response like where all these 8 people can sit in a perfect way, it means you're giving a better customer experience. But on the other hand, that will also require you for the more tokens. So now, one of the question which is, okay, even for LLM pre-training, there was a requirement of so much compute. Now with the long thinking and the post-training, the amount of the computational requirements even going higher. So what's the best way? Because at the end of the day, the entire world is very power limited. So how do we go and think about that problem? And that's why you go back to my first slide where I was talking about, hey, we are these 3 layers, but we are a full stack computing company. So the way we're thinking about these problems is how do we go and solve these problems at a full stack, right? It means you need the innovations, not only in terms of designing, from moving from Ampere generation to Hopper generation to the Blackwell, which is a recent GPU generation architecture. You, of course, need to keep on improving your compute architectures, but you also need to think about doing the innovations in your software layer, right? And one of the recent announcement, again, we can have back, we talked about what we call as a NVIDIA Dynamo. right? This is the inference software for reasoning, inference at a scale. When you're running these, you remember that problem, like there is sorry, just going back, the 100 topic areas, 1 million questions per topic, if you really need 100 trillion tokens, kind of the requirements, you need to think about running this inference at a scale and how you can really optimize that. So we released this software. It's open source, right? It has a lot of components. I don't have a time to go through in the details of each and every one, but a very simple way you can think about this is going to improve, some of the benchmarks we did, like for example, DeepSeek R1 based models, it will be 30x more performance improvement. And this is all the performance improvement coming because of the way you are writing the software, right? And the same way, like your 2.5x AI factory throughput and revenue based on the Llama based models, right? Another interesting part, because again, you need to do the innovations at the full stack. We continuously improving the software, but we are also thinking about what's the next generation. Our GPU architecture should be keep on improving. We will be coming up, the next version. Our current version is NVIDIA GB200 NVL72, as I talked about, and which is based on the Blackwell. And there's a Blackwell Ultra coming up, probably end of this year, early next year, which will have, if you just look at the FP4 performance, it's a 15 petaflop. I'm pretty sure in the room, there will be many people who might be remembering a teraflop of a supercomputer in the top 500 list. Of course, that was a FP64 performance. But still, if you see, like, if you convert FP4 to FP64, these single chips are so faster. And I'm talking about an exaflop of a supercomputing in one rack with GB300 NVL72. Right? As you can see the specs, which is like 1.1 exaflop. So why I'm sharing all this? The reason I'm sharing all this, because to really solve that problem of running this generative AI at scale with reasoning, with the post-training, you need to scale the compute. And to scale the compute, because this is a full stack computing problem, you need to solve that problem at every layer of your stack. And this is the bottommost layer where like you designing the best possible architecture like Blackwell Ultra. You're thinking about the right server and the rack designs, and that's where the GB300 NVL72 is coming. And then you're thinking about building your data centers in a way so that you can really take the cost down, right? And make these applications more accessible, as well as helping them to be more productionized. And if you see, the outcome was like, you are roughly getting around 50x AI factory output as compared to our own previous generation, right, which is Hopper based. This is like, just another way, because as I was talking about, we are also becoming more and more, power limited. So every generation and every innovation you do in the full stack computing, you also need to think about how power efficient you are becoming as you building these infrastructures for this age of AI. There's also another interesting, the factor which I would like to highlight through this slide. This is really around, we really talking about the 50x overall increase in AI factory, output performance, right? So, when comparing with, think of NVIDIA's GB200 NVL72 platform, to the previous offered architecture, the GB200, NVL72 delivers roughly 10x improvements, like tokens per second. But another interesting factor which you need to think about, when you're solving some of these problems, you have to think about the throughput and the latency, right? And when you're thinking about, hey, you need more and more throughput, but you need that throughput at a certain latency, right? When, for example, you take a simple example of a customer service, for having these reasoning and post-training interaction of your kind of AI agent, which is communicating with the end customer, you need, let's assume this tens of thousands of tokens every second, but you need to get these tokens and the response time to that within few milliseconds so that the interaction looks much real. So the throughput and latency both becomes a pretty interesting factor. Now the question comes, where you go and fit in on that curve, where like, how many tokens you can produce and how quickly you can produce those tokens. That's a pretty interesting and optimization problem. You can, you can always think through, and to be honest, I've even seen some of the companies, startups who are building and actually fitting in on that curve, right? But the key point, which I really want all of you to take out from this slide, how you can have more and more tokens being generated that directly resulting into the more revenues. And you have to see from one generation to another generation, it should be a leapfrog improvement. Otherwise, it will become very harder for the AI to move in the production because cost becoming a significant factor. So let's quickly, turn to the age of enterprise agentic AI. We all very familiar with the perceptive AI, where we were just detecting the patterns, to the generative AI, which is more of we were generating the answers, right? And then finally, we are like coming what we calling as a agentic AI, where you are not generating the answers, but you are also like thinking through, you reasoning about it. And then, one of the things which we very commonly talked about, right? Think of having a digital employees to do the job, right? Sorry, yeah. So if you remember in the beginning, I mentioned about that AI factories, what they will do, they will transform your data into the outcomes and how these outcomes are being modeled in terms of number of tokens. So you can think of a very simple way of your AI factory. It's producing the intelligence in the form of the tokens, and these tokens you can go and monetize, right? Just imagine if you go and look at OpenAI, or you look like like Google's Gemma and any other models, what they are doing, they're producing all the tokens, right? And these tokens you can go and use them to run any of the applications. So, given the time, I will not spend a lot of time how AI agents work, but I'm assuming most of you might have that background in terms of how the agentic AI is working. But a very simple way you can think about, agents are able to connect to the data, to the tools, and other agents, right? And they are used, for the reasoning as well as to tackle some of the complex problems, right? And they can also take the appropriate actions based on the reasoning and the kind of the long thinking these agents are doing on. Let me give you a bit of the perspective about, when you're thinking about building these agentic AI workflows, you need a lot of tooling and the sets. For example, just imagine any regular workflow like customer service. You might need something called a research assistant agent, which is really thinking through, right, and researching about what all need to be done. There is a customer service agent, there can be a security agent, there can be a virtual lab agent, there can be like many personas of these agents, right? Which you will go and run in your typical enterprise, right? And to do that, you need a lot of tooling as well as the infrastructure. The infrastructure part I really covered through the AI factory. And think of the tooling part. This is what, we have like two categories of the software, what we call as NVIDIA NeMo and NVIDIA NIM, right? So there are like curator, customizer, evaluator. There are many NIMs, and this tooling is available from NVIDIA, which you can go and access and which can help you accelerating this agentic AI workflow. Most of the software which I talked about, and even like Dynamo and all that, most of that is open source, so you can go and find. And if you if you're looking to even like take any other backend, right? For example, you can also go and consume the VLLM backend or any other backend. That's also possible, with this. Okay, these are like some of the very recent examples how we ourselves as well as some of our partners are really using the AI agents in the production. I think one of the example I always love to talk about is NVIDIA Chip NeMo. As you know, we we fundamentally also design a lot of chips, right? We design GPUs, we design CPUs, DPUs, right? We have many chips which we design. So there is no better way for us to last 30 plus years of this chip design data. We have taken that and we kind of the fine tuned, and then also like we're doing this long thinking kind of a thing, where we have these agents who are helping us to design the chips even more efficiently. And how it is helping, because now with these agents, they can go and write a lot of code, right? And they can really design, and then humans are coming to really like, hey, validating everything is done well, thinking through the design, and the productivity of all of these employees are becoming order of magnitude better than as we used to do that. And as you might be knowing, we have in our yearly cadence of the new architectures are coming up. So of course, we need to use some of AI by ourselves to ensure that we are able to, do some of these things, specifically the repetitive task. Some of the things which we know, oh, this is how it's all. Every time it works that way, we can just go and use the AI agents. And we ourselves as all employees focus on more on higher value activities, right? Of course, there has been two announcements which we did. I will not going to spend more time, like SAP's Joule as well as ServiceNow Now Assist platforms are also agentic platforms powered by NVIDIA. So this is what I was talking about, how we are using some of this agentic AI as well as AI applications within NVIDIA. Every designer has a co-pilot. AI answers the architectural questions. We have something called what we call as a bug Nemo, because there's no software without bugs, and we have like hundreds of thousands of them over the last 30 years of the data. We have AI which can go and look at all the bugs, summarizes, quickly do many things there. And of course, AI creates code in a specialized language. As you know, some of these work is done in some very specific languages. Another thing is like AI factories. We just want to ensure that this infrastructure is available everywhere, because this is where the intelligence will be manufactured, and it will be manufactured in the form of tokens. So you can find like, it in any cloud, in what we call as a NVIDIA cloud partners like CoreWeaves of the world, or you can find on-prem. It can be anywhere. It doesn't matter, right? It's your choice where you want to consume this platform. I think this is some of the examples of the recent AI factories. I think I was just talking about CoreWeave. There are Lambda, Vulture, Utah, Northern Data Group. There are many of these partners, right? Globally we have. And interestingly, a lot of telcos who are also working like as AI factories, and they are also becoming more of a sovereign AI clouds in many parts of the world. Okay. I will probably skip this slide. Maybe I would like to move to this slide. I think this is a different view of the same stack. And the reason I'm again trying to show it to you, I talked a lot about AI factories. I talked a lot about software, how all of these pieces are coming together and how the full stack is looking like. So you may think of, if you're working in FSI, you are a quant trader, you sitting somewhere here, but when you're thinking about your portfolio optimization problems, you kind of using the value of this full stack, right? And that's why with the same stack, we are able to go and address like a very large industries, like think of automotive or healthcare or financial services to retail to manufacturing to aerospace, right? The same platform can be consumed in many different ways, because AI and accelerated computing is kind of common across everywhere. Okay, probably this is my last slide. I was given like 25 minutes of time, so I'm almost on the time. I think this year, as you know, you remember 2018, like, okay, let me go a little bit back. 2012, 13, the deep learning era started. 2018, 19, like LLMs, kind of started with the transformer architectures, but really the iPhone movement in the Gen AI happened when the ChatGPT was launched in October 2022, right? And after that, we gone through that world of the pre-training. We really, last year, we did a lot of fine tuning, and some of the enterprises started getting adapted to the AI. And then finally this year, the way we see it is like it's going to be all over the agentic AI in all the enterprises. So this year will be really, really a lot of work will be done in that space. I think another very interesting thing, which I'm personally super excited about, is physical AI. Just imagine from now AI when it start taking the physical form. What does that mean? Think of like robotics. Think of like the automated factories. Think of like automated warehouses, right? The use of AI and specifically all these digital employees or AI agents which are running and doing a lot of these things by themselves, and they are taking a physical form like in form of robots or any other physical entity. I think that's the next big wave in the AI is coming. And I don't know the timeline, but still definitely it's not happening this year. It will take a couple of years, right? Because with the video foundation models coming, there's a lot of work need to be done. The another interesting point, which I would like all of you guys to go through, is that it's not only just the advancements in the computing, networking, the software, but we also really need to be very, very thoughtful about energy, right? And how power efficient all the data factories or AI factories which we are building in the future, because power will be the limiting factor. And then finally, I think we already have this today. We have this AI factories everywhere. You think of the entire world manufacturing. I know people already talking about manufacturing 4.0 or 3.0. I don't know what we will call it, 5.0 or something. But think of these manufacturing facilities, AI factories. They will be producing the tokens, producing the intelligence, which everyone can monetize in the form of the tokens. So now your data centers has really become from, they were kind of the capex like or as well as the opex, and now they're really becoming, they're no more a cost center. They're really the one who's helping you to produce the more revenues for you. So with that, let me take a pause, and I'm not sure if I do have any time for answering any questions. If yes, I'm happy to answer. Otherwise, happy to give it back to the organizers back. Yeah. So I think we are seeing a great traction in many industries, right? And enterprises are at the end of the day are tied to the industry. I think a great traction we are seeing some of, we call them as a more of an enterprise ISVs, but each one of these companies like SAP, like ServiceNow, Salesforce, Adobe. Think of these are the companies who are producing the software which will go and cater the hundreds or tens of thousands of the enterprise. There is a great traction, right? That's why I talked about SAP and ServiceNow, two examples, but almost every company which are kind of producing this enterprise software, they are right now reinventing themselves with the help of AI, generative AI, right? On the industries front, I see, there has some interesting works are going on across many industries, but one and two maybe I would love to highlight. I think one is really financial services. Banking is a pretty old industry, but just imagine with the agentic AI, the banking are being completely redefined. But it might still take a while because there is a lot of regulatory things in the banking and in the financial sector. But the other part of the financial sector is like capital markets. Think of the people who are working in the hedge funds or portfolio optimization kind of the problems. I think that space is moving very, very fast in adopting some of these technologies. I also see some of the work being done in energy industry, which is very exciting and interesting because they're thinking about like, how do you go and then have the smart metering concept, do the power balancing, everything, and they are trying to use AI. Even the grid efficiency itself is a big problem. Just moving forward, auto, we all know what's happening in the self-driving car world, but just imagine like at the end of the day, every self-driving car is kind of a robot, right? So think of autonomous machines as a space which is moving very fast, and that's going to impact each and every one of our lives in the next few years. I think that's the part we are super excited about, and that's why I was talking about physical AI. It will still take few years, will not happen this year, but there's a lot of work going on. As you can see, there's some great startups that's come up. Most of them are working on our platform. And yeah, And then last point, probably I will mention, which is like more of a sovereign AI, because every country in the world, and to be honest, every enterprise think about that AI has to be done with by their own way. Because as I was giving you the example of the chip Nemo, because chip Nemo had NVIDIA's learnings and know-hows of designing the chip for last 30 years. That has to be done our way. Similarly, if you go and run these large language models or just generative AI, let's say you run it in India, and if the language doesn't understand Hindi and the culture there, it does not make sense. People will not be able to use it. So that sovereignty concept in the AI is also becoming very, very popular, right? And you will see a lot of work, and a lot of these AI factories are coming around the world because everyone needs to have their culture, their language, their know-hows about their society to be captured as a part of these elements.
Thank you, Pradeep. Given you were able to do this remotely, the experience was very compelling. You did a good job making sure that we were able to understand and go through your very highly technical presentation. So really appreciate it, and thanks for making the time. And next up, I would like to invite. I think let's shift our focus to computer vision, one of the most transformative fields in AI today. It's an honor to introduce Satya Malik, a true industry leader in computer vision and deep learning innovations. I'm meeting Satya for the first time, but it's interesting. I met Satya through my fitness trainer. And it's very interesting. While we are doing training, we talk a lot about AI and things like that. But and then he started talking to me about Satya. Satya is, by the way, he's a PhD from UCSD, and he's CEO of OpenCV.org, the organization behind world's largest open source computer vision library, used by millions of developers and AI practitioners worldwide. So I think he has made a huge impact to the industry here. With over 20 years of expertise in AI, deep learning, and real-world computer vision applications, he has been instrumental in advancing the field and democratizing access to cutting-edge AI tools. He's also founder of Big Vision, a consulting firm specializing in AI, machine learning, augmented reality, and video analytics. Passionate about education, Satya shares his knowledge through learnopencv.com, one of the most widely followed resources dedicated to computer vision advancements. With that, Satya.
Thank you, Naresh.
You have to ask me to scroll because your PowerPoint didn't work with PDF, unfortunately.
All right, that's fine. So this is that time of the day when I have to ask everybody, are you awake? Give me a yes. Yes. Yeah. Yes. All right, yes. Thank you so much. So I'm going to talk about, it's going to be more technical than other presentations. I'm going to talk about VLMs. So a lot of people have heard about LLMs, which is large language models. But now models are getting multimodal. Specifically, VLMs are vision language models. So I'm going to give you a technical presentation on what they mean, right, how they operate, and some applications of it. Next. But before we do that, I like to say that I wear many different hats. I'm the CEO of Big Vision LLC. This is a company that maintains the biggest, this is a company that does computer vision and AI consulting. We have been around for 10 years before AI was hot. And I'm also the CEO of OpenCV.org, the organization that maintains the biggest computer vision library in the world. It's downloaded over 1 million times a day. And lastly, I'm a blogger. We write technical tutorials at learnopencv.com. Right, next. So in this talk, this is a talk about vision language model. And I'm going to first explain what is a vision language model. And we will spotlight a model called CLIP. And then that will help me explain what a vision language model is. Then we'll spotlight another model called DeepMind Flamingo. And finally, we'll go over two kinds of applications, general applications, and some applications that my company, Big Vision, has done in the recent past. Right. So by definition, vision language model, it's a kind of model that takes into account both photos, videos, and language, right? And the input to these models is typically images, videos, and some text. And the output is text. But now the models are getting more sophisticated. They can output images, videos, in addition to text as well. So there are two components to it. Large language model and the vision component, the computer vision part of it. Large language models, they basically are trained on very large data sets, internet scale data sets. And what they provide is, the way they are trained, the basic training is to predict the next word. Given a context, right, given a piece of text, they predict the next word. That is the basic training. And you may be thinking that, how does it even work, right? Large language models are they are capable of doing so much. How is this simple training where you're simply predicting the next word useful? And let me give you an example. Let's say you're reading a mystery novel, a murder novel. Somebody died, and you're finding the murderer, right? And at the end of the novel, they are able to discover, given all the clues in the novel, it says the murderer is such person, right? So just to predict that last word, you have to have a lot of context. You need to learn whatever was presented as evidence in the novel. Then you need to reason that this evidence is right. You also need to know the context, right? The cultural context. For example, if somebody said, I killed it, doesn't mean they actually killed a person, right? So that is why, just to predict this last word, the name of the person who is the murderer, you need to understand everything, right? And that is why large language models are so effective, even though they are trained on a very simple idea of predicting the next word. This analogy was actually borrowed from Ilya Sutskever, who is a top researcher in the field. Now, the second part is vision, right? The question is, why do we care about vision? The thing is, vision data is very, very dense, right? We can learn a lot by looking at a picture. And in fact, 30% of human brain is dedicated to vision analysis, visual analysis. Compare that with speech analysis. Only 3% of our brain is dedicated to speech analysis. And in fact, if you ask my wife, she'll say that I don't even use 3% of my brain for that purpose. But then, that is why we want to analyze videos, and we want to analyze images. And they basically, compute is cheap, and that is why we are able to do it. In contrast to language models, this is how vision models are trained, right? Let's say we want to do an image classification task, which means that given an image, you want to classify them into different categories, cats, dogs, et cetera. Right here, we have 9 categories. And you can see that what we need to do. First, we need to get image, like thousands of images. We need to label all these images as cats, dogs, and whatever the categories are. They have no knowledge about the world, right? We train them, and given an image, they are able to categorize them into one of these categories, right? But they are very precise, right? We know exactly what we want to do. Next. So here's the difference between computer vision and LLM. First, trained using supervised learning, which means that we need to provide them image and label pair. In LLMs, we did not use supervision. We just get the data. No annotation needed to be done. Humans did not have to go and annotate each and every text. The first one is trained using millions of images. The second one is trained using internet scale data. The third is they understand classes they are trained on, so very limited understanding. But the LLMs, they are trained on world knowledge, so they have world knowledge. And the final thing is that they are very task-specific. Computer vision models are very task-specific. On the other hand, LLMs are very general. Okay? So now we want to combine the two things. Computer vision will provide rich information, and LLMs will provide world knowledge to our solution. All right? So that brings me to this model called OpenAI CLIP. And CLIP is a contrastive language image pre-training model. That's a mouthful, but what it means is it's a multimodal model. and it is trained on image caption pairs. So if you look in the internet, most of the images will have something called alt text. So people who cannot see the image, blind people, and also for robots to interpret, for SEO purposes, they always have alt text. So you basically take the image, and you take the caption from the image, or the alt text from the image, and then you train this model. The idea is to do something called zero-shot classification, which means that without training, you're able to classify an image into the categories I mentioned, like cat, dog, etc. If you go to the next one, and the way it is done is they encode the image into a vector space, right? So given an image, they use a vision encoder and encode it into a multidimensional space. Most of us cannot imagine a multidimensional space, so think about a three-dimensional space. A point in three-dimensional space is representing an image, and some magic has been done to convert this image into a point in three-dimensional space, and similar magic has been done to convert text into a point in three-dimensional space. And now, if you have a mechanism to compare these 2 points, and it says that they are similar, you have achieved the goal, right? So that is what is the idea of shared embedding space. You encode images and text and any other data, actually, even speech, into the same space. All right, so here, you can see that the person wearing the mask and the image of a person wearing a mask, they are similar concepts, and they are encoded, and the similarity measure, which goes from 0 to 1, is very high. But if you take, move next one. If you take an image and text that don't match, in those cases, the similarity measure is low. Earlier, it was around 1. This is 0.73, right? So that is the kind of space clip training enables us to do, all right? So now, like I was saying, it's not actually a three-dimensional space. It is a space of, let's say, 512 dimensions. And here you can see that there are 2 objectives. The first objective is to minimize the distance between an image and its label or its caption, and maximize the distance between 2 different categories, right? Let's say we are talking about 2 different images, 2 different text as well as 2 different images. They should be maximized in the space. And that is what CLIP enables us to do. So here's how it goes, right? Once we have trained this model, CLIP enables us to do something called zero-shot classification, right? So before I explain what zero-shot is, let's say how classification is done in a traditional way. Let's say you want to build this classifier. You have an image of a cat, and you want to classify it into categories. As I had mentioned before, you'll actually take thousands of images of cats, dogs, and horses, and then label them cats, dogs, horses, and then you're able to train a model. Now, suppose your problem changes. Now you want to classify elephants also. Now you have to go back, you take thousands of images of elephants, retrain the model. It will take you a few days. And depending on the complexity of the problem, it can be months, right? Now, let's say, how do you do it in zero-shot way using CLIP? Can you move to the next? Yeah, in CLIP, as we know that an image can be embedded into the space, and then you compare the embedding with text, right? The text embedding. If they are close, you can say, okay, this is the image of a cat. So you have this image of a cat, you compare it to the embedding of all these, a photo of a cat, a photo of a dog, photo of a horse, and you have a classifier, right? Now, let's say you want to add this class called elephant. How do you do it? You simply add a text that says photo of an elephant. You calculate the embedding and see whether it matches or not. So in a few seconds, you have done image classification, which used to take you a few days, right? And that is because these things have world knowledge, right? They know what a horse is, right? Or an elephant is. So CLIP is typically used for zero-shot image classification, text-to-speech, text-to-image search and retrieval, guiding image generation models. Some people may know about diffusion models like Stable Diffusion, which is used for image generation. Inside the diffusion model, they use CLIP to make sure that the prompt that you're giving and the image it is producing, they are related, right? They are producing the right one. And then for image captioning, annotation, and then multimodal moderation, content moderation. You can think about simple things, right? let's say you want to do multimodal content moderation where there's a meme. If you look at the image alone, it may not be a bad thing, right? It may not be offensive. But if you look at the text below it, that may be actually creating the problem. If you analyze them together, then you know it is actually offensive, right? So those kinds of things can be done using CLIP. So just to give you an idea that when we talk about VLMs, we are not talking about the same thing, right? Every VLM is different. They're trained for different objectives. They're trained for different outcomes. So here is a DeepMind Flamingo. It's a large model, 80 billion parameters, and this is trained for few-shot learning, which means that, I'll show you an example of what few-shot learning means, but it outperforms fine-tuned models on 6 out of 16 tasks, right? There are these benchmarks people evaluate, and this was very impressive at that time, 2022, when it outperformed many of these. And this is a completely different model, right? In the previous example, we were training using image and caption pairs. Here, it is trained on free-form image and text sequence. For example, a web page may contain images, it may contain some text, it may contain other images, more than one images. It takes all that information and trains the model, right? And here you can see the way it does it is, if you look at that thing that says interleaved visual text data, you can see it's showing a dog. This is a very cute dog. And then the cat, this is, and you want to find the completion. The input is basically that whole sequence of images and text. And it is able to first extract the text and run it through a large language model, extract the images and run it through a vision encoder, and then interleave them and then use that information to do the final prediction, right? So the answer is a very serious cat, right? The completion it makes. So this now is a very different model than CLIP, right? Even though they are all called visual language models, doesn't mean that the architecture is same, the objective is same. Here, for example, this is the input prompt it takes, and this is an example of few-shot learning. The input is an image, and then we say, this is a chinchilla. They are mainly found in Chile. The second image we give, it's a dog, right? This is Shiba. They are very popular in Japan. Now the model has learned through these two examples what we want, right? So we say flamingo, we give an example of flamingo, and we say the answer is, this is a flamingo. First it says, what is the type of object? Second, it says something about the geography, right? About the location. And look how little information. There are just 2 pieces of information we give the model, and it is now able to predict what the task is, right? That is called few-shot learning. Similarly, in the second example, it is giving handwritten math, right? And it has to interpret what the math is and then give the final solution. So you give 2 examples, and you get the answer. 3 times 6 equals 18, right? Very different models. Keep going. Flamingo can also do video analysis because it can take any random sequence of videos and text. So you can actually say, you can give it some video frames and say, what happens to the man after hitting the ball, right? And the answer is he falls down. So a very powerful model that is trained on a combination, a sequence of images and text. Keep going. OK, I think it's the same slide. So let me just pass over that because I don't have much time. But you can see that in this example, there is a single image, and you can have a conversation with that image, about that image with this AI, right? Keep going. The next example is you can also have a collection of images. So you have 3 flamingos here, and you are talking about what is common between them, and it is able to say that these are flamingos, and then you can have additional conversation about it. Another example, and then we can keep going. And another example where there are 2 different images put as in 2 different times, right? So Flamingo is able to do this kind of chat. Let's keep going. So yeah, the thing that I wanted to emphasize is that VLMs are not all the same. The inputs are different, the outputs are different, the objectives are different. Some are for zero-shot image classification, some are trained for chat-like interfaces, some are used for multimodal reasoning. And the architectures are different, the tasks they are trained for are also different. Keep going. So let's show some very common applications of these VLMs today. They are used in e-commerce and retail, for example, for product search, et cetera. They are used extensively. For customer service, you can have, let's say you have an appliance problem. You take a picture of your appliance and put it in chat, and it's able to analyze not just your text, but also the images together and give you a response. Content moderation, I gave you an example. Marketing and media, you can produce all these images. In fact, most of the images produced in this talk were using ChatGPT, right? The newest ChatGPT, I replaced a lot of images that I had manually done. These ChatGPT models were just more efficient. And also in healthcare, you can guide a doctor to analyze, right? You don't have to, the state of the art is not such that you can rely completely on these AI models, but you can guide the doctor to put their attention into specific areas of, say, let's an X-ray or something like that, right? Here are some examples of a project that we did through my company, Big Vision. There is a company that came to us, and they wanted to analyze food for calories, like take a picture of this food, find what is it, what's in it, and also find how much calories it is. So this is an example. It is able to look at this plate and say that, OK, we have a salmon, broccoli, and rice, right? With 90% accuracy, with 90% confidence, it is saying that this is the result. Another example, here, when we do not have very accurate requirements, right? Sometimes we need that, OK, there are 5 people present in this room, and I want to detect exactly this 5. Then VLMs may not be the right solution, but let's say you want to detect an approximate number. In this case, we wanted to detect whether there are 2 or 3 food items, or 4 or 5 food items, and so on. And an LLM was able to produce this result for us, right? We were able to just, in one shot, in very few shots, we were able to determine how much food is there. Not exactly, but approximately, OK? Here's another example. You want to take a picture of your shelf, bathroom cabinet, and figure out what are the different items in it. So we first used an object detector, which was detecting all the objects. And then from there, we also wanted to analyze what's inside, right? Which object is it? Without any training data. We had 0 training data for this, and yet we were able to solve this problem. But here's the interesting thing. What's visible here, let's say that Aveeno product, what's visible here is not the entire story. We are also able to output other information about the product because the vision language model also has a language component which is trained on internet scale data, right? So now we are combining this very precise information with internet scale world information. It is able to output not just what's visible, but also what it knows about this Aveeno product, right? So very powerful ideas have come out. So this is just product 2, product 3, and product 4. We can scroll over them. All right, and ChatGPT also is used, the Omni model, which is basically a multimodal model, is used for various applications, as you know. And this Flamingo model that I mentioned is used by YouTube for finding the description of YouTube shorts. Yeah, that's pretty much it. Challenges, these are data-hungry, compute-intensive applications. The accuracy sometimes may not be as high as finely tuned models. There is obvious bias and fairness issues because they are trained on internet scale, and it's not possible to analyze them, the data itself very closely. And that is why we also have problems with interpretability and modal limitation. This is being solved right now. If the input is multimodal, the output should also be multimodal, including speech, which is already happening. So, all right, so that's pretty much it. Thank you. Yeah.
But can you comment on hallucinations?
Yeah.
I heard the term beware of AI.
Yeah. Actually, everything is hallucination, right? It has, if you think about it, everything is hallucination. There are right hallucinations and there are wrong hallucinations. But there is nothing, when the model is trained right, then you have to reduce hallucination. Hallucination will always be there. It happens in the human mind also. You can be 100% sure that you saw something, but that was not true, right? And the way neural networks are encoding all this information and then recreating it. So everything, even when it produces the right answer, it's a hallucination. It's just the right hallucination, right? And there are techniques to solve it, right? And people are using it. You can see the progression, right? If you use the ChatGPT free model, it hallucinates quite often even now. But if you look at the $200 per month version, it nails the problems, right? It has reasoning embedded in it, it does multi-check. So the more amount of time you're able to compute, you're able to spend on coming up with the answer, checking your answer, it actually reduces hallucination quite a bit. Is there a unit of measure? There's accuracy measures, different accuracy measures, but yeah. I don't know the exact number off the top of my head.
Let's take it.
Yeah. Yeah.
No more questions.
Yeah.
Okay. Thank you so much.
Thanks, Satya.
Yeah.
This is amazing presentation. Thank you. And what we are going to do is change the schedule a little bit so we can take a coffee break. Instead of 20 minutes, we'll have like 10 minutes, and we'll be back in 10 minutes.